Hello everyone, welcome back to my video. So in this video I will show you how the byte pair encodings are working here with all the sentences. Well, continuing from our previous videos that mentioning about tokenizer, yeah, as we might know that lot of the tokenizers method, yeah, see from the characters level tokenizer, sentence piece, yeah, byte pair encodings, and the third parties tokenizer like OpenAI and many others, yeah. Okay, so here I have data set. It is the novel actually. Is Sherlock Holmes PDF. Okay, so it is written on the Bahasa Indonesia, yeah. Okay, that the main purpose of this byte pair encoding, yeah, later on we will pair with the positional encoding and continuing with the embedding process, yeah, and then feed it into the transformers model. Okay, on this episode we are still using the text generations model. Okay, well, because the question and answer model will come into the very complicated explanations, yeah, and the very complicated mathematical calculation. But don't worry, we will come into that part later, yeah. So we stay on this video. Um, I will explain how to build the large language model from the scratch, yeah. I mean, from the data sets, all the sentences. As you might remember that the previous video, I trained the 2 million characters level tokenizer, yeah, with the text generations with the LSTM. Okay, but the LSTM is very simplified, yeah. Okay, so that also has different method, yeah. Okay, well, this kind of byte pair encoding actually it is the tokenizers method, yeah, one of the tokenizer method that would like to fit into the transformers. Okay, so instead of the converting PDF inside of the program, I separated the programs with the Python's converter, yeah. Here we have the PDF to text converter, yeah. Yeah, I will give the file for free for you, it is not a problem. Okay, so these are the result of the conversion. Okay, I clean up all the text and the sentences, yeah, from unnecessary characters like white space, you know, and double colons and etc. Yeah. So this text has already cleaned up, yeah. So it is made easier to the model to get into the byte pair encoding algorithm. Okay, so here are the things. First, I'm creating the unknown tokens, yeah, and then the second beginning of the sentences and end of sentences tokens and path of the tokens, yeah. Well, even though all this text has been cleaned up, but I'm still using these unknown tokens. Yeah, well, probably there is some still missing characters still including on the text conversion. Yeah, so that's why we need to create also the unknown tokens. Okay, because this is will generated the sentences with the byte pair encoding result. Yeah. Okay, so from there we got the encoded numbers that ready for the next process completion. Yeah. Okay, so yeah. Okay, hopefully this will generating the JSON file, yeah, from this result. Okay, yeah, this is a reject. Starting pre-training. Well, here as you can see that the BP training, it is load on the CPU, yeah, instead of the GPU. Remember that the last videos I was using GPU to train all the model, but this time I'm using the CPU. Okay. Okay. Well, here basically the questions of the byte pair encoding result, yeah, based on the training. Okay, so this kind of Holmes data set, actually it is a data set trainings. Okay, then from those training it will generate the JSON file. Okay, so from the JSON file as a best vocabulary data set. Okay, so from there all these kind of sentences will be referred from this vocabulary text here, this vocabulary results from the training. Hopefully it will works. Yeah, and then if it is all work, then the next step will be continues into the positional encoding, and then we feed it into the transformers. Okay, so here telling that the JSON data set, yeah, the JSON, the library vocabulary that load into this kind of a program that will be as reference for this kind of text. Yeah, so this byte pair encoding will work, will chop off all these every subword, yeah, based on this JSON's vocabulary. Okay, yeah, well, Barbara, I think that's it. Yeah, now it is coming into the 8,300. I think she's almost finished. Yeah, now they are trying to get this training text tokenizing from this text. Yeah, from this text. Okay, guys, I think I have we have to wait, yeah, until all this finish, then I will come you later. Thanks, see you later. Okay, now we are facing into the merging trainings completely. Yeah, as you can see here that the BPE training was already completed. It generate the 8,400 something vocabulary text, and the merging rules about 8,300 something as well. As you might see that the merging numbers It shows it's supposed to be 10,000 here, but it is stopped at the 1,300. It means that the mergings for 10,000s it is over limit, yeah. So the maximum mergings are only taken about 8,300. Now it's completed. Okay, so as you can see here that the model generating the JSON file, which is inside of these JSON files, the here it is chunks, yeah, of the subword encoding with the number as well. Okay, so totally for these documents about 41,000 something, yeah. Well, seems that the BPE training was successful, yeah. Okay, so now we can see here the chunks of the text here. It says that the characters here, there's 15 rules of character, which is already merged, yeah, on the sub character and generating the new vocabulary. Okay, so here the result, yeah, of this text. Suppose that we have the Sherlock Holmes adalah detektif terbaik. The character counts about 39, yeah, and this is the tokens encoding that creating by BPE. Okay, so this backslash W is the N, I think, yeah. 1 2 3 4 5, yes, it's 1 2 3 4 5 with the tokens ID as well. One, yeah, sequence, the starting sentences, yeah, and every single chunks of the words it took slash W, yeah, means this is the telling that is the sign of this end of this word. So this token sequence based on this BPE. Okay, as you can see here, that is 1 2 3 4 5 6 and 7, yeah. Instead of 1 2 3 4 5 6, it is generating the new vocabulary of this E K T I and F. Okay, so this is the token ID. And this is the other example, yeah. Pembunuhan yang dilakukan dengan sengaja. This is 1 2 3 4 5, and the token sequence generated by BP is 1 2 3 4 5 6 7, yeah. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so one is the starting of the sequence, as you can see here at the here, yeah, at the program we determine the here we generating the unknown tokens and then the starting tokens, yeah, and of sequence tokens and also the path. Okay, so on this processing encodings when the okay, so here we are generating these unknown tokens, and here in the bracket S and slash S and path, this is telling that the start of the sentences, and the slash S is the end of the sentences, and the path is referred to the empty space, yeah, or a white space or something like that, yeah. Okay, so on this example, I mean, it is successfully creating the new tokens idea. Okay. Okay. And here's another example ya, ketidakmampuan memposisikan penjelasan. It's generating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so this is starting of the sentences as the slash s is the end of the sentences, yeah, and this is all the result of the BPE algorithm. Okay. Yeah, this is another example. Okay. Okay, so this summarize the process that the text character text is about 2 million characters, which has yeah, I think 428 something thousands text tokens. Okay. Okay, so yeah, I think that's it. Yeah, as you can see that these BPE are running successful, yeah, to do the tokenizer of the Bahasa Indonesia. Okay, so from this point we can continue into the next level, yeah, before we are feeding into the transformers. Okay, so from here that we can do the embedding, yeah, and then we do the positional encoding later on, but I think said well the first try we can have the BP we can have the positional encoding first. Okay. Okay, yeah, I think that's it. Yeah, all this program was running successful with the byte pair encoding using Bahasa Indonesia. Probably you might try to other language, and if you have the result already, please give the comment on the down below. Okay guys, I'll see you in the next video. Thank you for watching. So for your information only, that probably the byte pair encoding for Indonesian language are taken from this document. Yeah, it was created by University of Indonesia, the Computer Science faculty, and the Linguistic Department of Australian National University. Yeah. Well, if you probably need it, you can have a look. Yeah, there's a lot of methodology inside here, but when I did the byte pair encoding, I just referred to the algorithm. Yeah, I didn't see this document, but when I search on the documents reference, I found this. Yeah, well, probably this is only the supplement, yeah, to get the byte pair encodings done completely and very close to the prediction. Yeah, I think. Yeah, well guys, if you need it, I can put it the link down below, so you might have a look. Okay guys, see you in the next video.